In this video we will see the inverse functions for sec, cosec and cot. In a previous video we have seen the inverse functions for sine, cos and tan. For the rest we will see here, and also we will see what are the domain and range for them one by one. So first of all, let me draw the line y equals to x to take the reflection for inverses, and then we are taking the graph of the cosec function. So this is the cosec function. It has a lot of branches, and to make it invertible we have to take a branch so that it becomes injective. So clearly from the graph you can see we have to take the parts x equals to pi by 2 to minus pi by 2. Sorry, x equals to minus pi by 2 to pi by 2. So let me restrict it. So this will be the graph for cosec x within the range within the domain minus pi by 2 to pi by 2. Now also let me draw the lines pi by 2 and minus pi by 2. So these will be the lines. This line is the left one is the minus pi by 2 line, the right one is the pi by 2 line. So clearly you see within this domain the function is injective, and also for the, if we draw the lines y equals to 1 and y equals to minus 1, we can see that the graph is also having the range, the whole set of real numbers except the part minus 1 to 1, because for this part the function doesn't have a trace. So we can say the range for cosec x is r difference minus 1 1, and the domain should be minus pi by 2 to pi by 2 is okay, but see on the real line it is not touching anywhere. So we can say for the domain of cosec x there should be no 0 point, because the point x equals to 0 is excluded. So what we can write here is that for the function cosec x, the domain should be closed interval minus pi by 2 to pi by 2 difference 0. We cannot take the point 0 because at the point 0 sine becomes 0, so cosec will become infinity. That is happening here, so that's why the domain should be this. And for the range you can see the graph is only above the line x equals to y equals to 1 and below the line y equals to minus 1. See, this point is 1 and this point is minus 1. So we can see that above y equals to 1 there is a part, and below y equals to minus 1 there is a part. So we can say that the range of this function should be nothing but r difference the set minus 1 1. It is the open interval minus 1 1. So these are the domain and range for cosec, so that it becomes bijective. So what should be the inverse? So let me show the inverse function for this. This will be the inverse function for cosec x. Okay, so let me deactivate the lines, horizontal and vertical lines. See, this is the red one is the cosec inverse function. It is clearly the reflection of the green one, because this green part is going here and this green part is coming here. That's how the reflection is doing its job. Also at the below, again we can see this green part is coming here and this green part is going here. So clearly it is the reflection about the line y equals to x. That is the cosec inverse function. So now the question is that what is the domain and range for this cosec inverse? So let me deactivate cosec and activate the lines x equals to 1 and minus 1 and y equals to pi by 2 and minus pi by 2. See, for the line x equals to minus 1 and x equals to 1 means these two lines, these two points are x equals to 1 and minus 1, and accordingly the vertical lines are the lines x equals to 1 and x equal to minus 1. And see, between the values minus 1 and 1 the function has no trace. So we can say for the domain this part will be excluded from the set of real numbers. And for the range, you see we only have the values for minus pi by 2, the below green line to the upper violet line, the horizontal green line to the horizontal violet line. Those lines are minus pi by 2 and pi by 2, and you can see that within this range the function is defined. So we can say the range should be minus pi by 2 to pi by 2, except at the point y equals to 0 the function is all over defined. So finally we can say for the function cosec inverse, the domain should be r difference minus 1 1 and the range should be minus pi by 2 to pi by 2 except 0. So that should be the domain and range for cosec inverse. Okay, so that's all for cosec inverse function. Next we come to sec inverse. So first let me deactivate these lines, cosec inverse and all this. Now we are drawing the curve for sec. See, this is the curve for sec. It also has a lot of branches, and again we have to choose only one branch so that it becomes bijective, so that invertible. So you can see clearly that it will be bijective for the range 0 to pi, and middle of that the point pi by 2 will be at the point pi by 2 the function is not defined, it is becoming infinity. So first of all we are drawing the lines x equals to pi and x equals to 0 means the y axis. So see, within these the function will be injective. So let me draw it for sec function sec x within the domain 0 to pi. Clearly it is injective, and if we choose the range to be the whole set of real numbers except minus 1 to 1, because within these lines again you see the function has no trace. See, within this range the function has no trace, and also at the point pi by 2, let me draw the line x equals to pi by 2. So see, the graph is not touching the line x equals to pi by 2, and also within the range minus 1 and 1 the function has no trace. So we can say that for the sec function the domain should be 0 to pi excluding pi by 2, and the range should be the whole set of real numbers except -1 to 1. So we can write for sec the domain should be 0 to pi except pi by 2, and the range should be r difference -1 1. Okay, so it is clear. So within this range the function will be invertible, and so now we are defining the inverse function. So the red line is the red graph is the inverse for sec. So let me remove the lines first. Now see clearly, it is the reflection, the red graph is the reflection for the green one, because this part is going here and this green part is going here. So clearly we can see it is the inverse for the, it is a reflection for the line about the line y equals to x, and clearly it is the inverse for sec. So the next question, what are the domain and range for this sec inverse? So let me deactivate the line for sec, and let me activate the lines x equals to 1 and -1 and y equals to pi. See, between x equals to 1 and -1 the function has no trace, so it will not be in the domain, and you can see the whole function is defined only for this range 0 to pi, because this line is pi, this point is pi. So we can say that the domain for sec inverse is r difference -1 1, and the range should be it should be 0 to pi except the point pi by 2. Okay, so these are the information for sec inverse. Similarly, for cot inverse, we will plot the graph of cot inverse, and then come to its, we will plot the graph for cot, and then I will come to the cot inverse function. So basically this is the graph for cot. Clearly you can see it is also having more than one branches. So to make it injective, first of all we have to choose the domain, and see, if we draw the line x equals to pi, we can see within the domain 0 to pi the function is injective. So first of all we are defining the function within that range. So see, this is the range 0 to pi, this point here it is pi. So within 0 to pi the function is injective clearly. And what is the range for the function? You can see clearly that the range is the set of real numbers, whole set of real numbers, because the function is defined all over it is covering the whole y-axis. So we can say for cot inverse, for cot the domain is only 0 to pi. Also see, the graph is not touching the vertical lines, so these brackets will be open. So it is open 0, open pi, and the range is the whole set of real numbers. So for this domain and range, the function cot is defined, and it is bijective, so it is invertible. So we define its inverse function, cot inverse, and that is defined in this manner. Also, let me deactivate the line x equals to pi. See, this is the red line is the graph for cot inverse. So clearly you can see, for this green part the function is reflecting here, and for this green part the function is reflecting here. So that's how we get the reflection, that is the inverse of cot. So clearly our next question should be to find the domain and range in which the cot inverse function is defined. So first of all, I am deactivating cot, and I am activating the line y equals to pi, and also, okay, this is enough. So see, the graph is defined all over the x-axis, so we can say the domain should be the whole set of real numbers, and only within the range 0 to pi, because this line is pi, within this range 0 to pi the function is defined. So we can say the domain should be the whole set of real numbers, and the range should be 0 to pi. Again, the graph is not touching the line y equals to pi and the x-axis. So clearly those two values 0 and pi will not be in the range. So the range will be open interval 0 pi. So let us write that for cot inverse, the domain should be the whole set of real numbers, and the range should be open interval 0 pi. So that's what we see here for cot inverse. Okay. So that's all the inverse functions, their domain and range. And also remember, all the domain and range here we have seen are all for principal value. So within this range we get the principal values of these functions. So in the next video we will discuss about the formulas in inverse trigonometric functions.